Yes, cpptcl is not new. It is not new at all. So, you can all just go click on the wiki right now or get it with your iPhone. And there you go. Okay, we're on, right? Everybody knows cpptcl. There you go. Let's start with the joke, right? Got everyone's attention. So, cpptcl is not new. Created in 2004, amazingly, on SourceForge. It amazes me because the C++ is pretty intense, and I did a lot of C++, and I remember how C++ was, and it was not fun. And so it was definitely quite reasonable at the time that it's questionable if it's worth the exposure. But now it's many years later, and we're going to talk about how C++ has changed. FlightAware, we started with it in 2017. And I remember when Carl showed it to me, and he said, hey, what do you think about this cpptcl thing? Can this solve our problems? And I looked at it a little bit, and I said, you know, the more I'm messing with this, the more I'm really, really liking it. So we did add some enhancements, and we implemented some more documentation. We moved it to GitHub, we put it in Markdown. We're trying to make it basically not have any things that would date it. So let's talk about some technical stuff. Everyone that gets to hear this talk, the audience is potentially split. A whole bunch of people totally understand what's going on with the Tcl extension, and there's probably someone in here who is like, what's a Tcl extension, right? And so I just have a couple slides really quickly so that if you're in the class of like, I don't know what a Tcl extension is, that you absorb enough keywords that you're going to be able to navigate in the future. So normally we put new commands into Tcl by writing procs, for example. And if we want to put new commands in with C, we write a Tcl extension. To keep it really simple. The mechanism that it uses is dynamic loading, which is a really, really old thing back from the mainframe days, which means split your program into pieces, load pieces of your program at runtime. If you're a Java programmer, Java jars or dynamic loading is a big feature of Java, right? But if you've never been doing C or making libraries or doing dynamic loading, it's kind of mysterious. So what is a Tcl extension? We write a program in C or C++ or any language that we can compile that would put it into a shared library, which is a special file that you can load at runtime. So you've got your program, you're going to load another piece into it. Then it calls the Tcl C API to extend the Tcl interpreter with new behaviors. It doesn't necessarily have to be a command, it can be a type, it can be many things. And of course it is dynamic loading is the way it works. It uses DL load, Tcl load command. So why cpptcl? So every day what I look at work is performance. I can't think of anything I'm working on that is not got major performance dimensions in it. And that, messes my skill set as a programmer that's done a lot of languages, level stuff. So C++ is very close to the operating system. If you want to do explicit memory management, you can. You get every kind of multi-core technique. You don't leave anything off the table. It's jack of all trades, right? And it has a very high quality development platform. Carl talked about how we were working with Swift, and the Swift Linux platform was abysmal. The FreeBSD Swift platform was non-existent, and Swift's event dispatch was based on the library Grand Central Dispatch. That had not been updated in like 8 years. It was really grody. We now have a completely different event library that's been created for Swift, which is not Grand Central Dispatch. But at the time, it was really clear that Swift was not going to work as a native language. So, like, well, let's just write it in C++. Okay, C++ has changed a lot. So when I say C++, I mean C++ 17. If you're not on C++ 17, you don't have very many rational reasons to not be on C++ 17. We actually use the thing to the far right, which is string view. String view is getting all the good things of strings and string functions and methods without the memory overhead of creating things and mallocing. And let's avoid all of that, have our cake and eat it too with strings. And so this has always been in C++ in libraries like Boost, but now it's actually part of the core. Parallel techniques are part of the core. The core language and the platform support is very good at this point. So with Ubuntu Bionic, you're completely ready to go. Every package they ship is of a significantly modern version to be completely functional. On OS X, there's no credit that you're in a very good C++ environment, and a lot of this I would attribute to Clang. So I was talking to somebody last night, and I said, hey, here's two good things about C++. If you use modern techniques for pointer management, for lack of a better word, or memory management, you can get out of memory leak hell and do double free hells. It requires your programmers to write sanitary code, but it can be done. The other thing is templates, which I'm going to actually explain a little bit about later in the slides. But templates let us generate all the code we need for specific situations and get rid of that if. That would have had to have been in front of a little piece of code. These ifs matter now. If is what kills a modern chip. If we can get rid of the ifs, things are faster, right? And we're really at this ridiculous level of optimization. I read a paper the other day, and the person was addressing optimizations that were fixing a cache miss faster than a cache miss. And I'm like, wow, this is really a lot of work for a very, very small change. And he says at the end of the paper, this causes our product to run 2 times faster. The net, they do so many operations. This is the core operation, doing that a little bit faster. And the technique they use is state machines. So you actually have an instruction in the Intel chip that says, here's a variable I'm going to read. Start getting it. Then you go and do something else and come back and access that location. And it's a pain to write, but it's it works and it makes it faster software. So we want to be able to have really high performance. So what do we do? This is our process. Find the hotspot, look at the Tcl and see if it has a gross error of the programming, which happens frequently. It was, who knows what the person, they might have been thinking about different objectives when they wrote it. And then we will either write a Tcl extension to address the hotspot, and in some cases we just have to replace the program entirely, because we just cannot. Once we fixed A, we have to fix B and C, and before we know it, we're at Z. And we're like, uh-oh. So usually configuration will survive because that's not an ON thing. If it's O1, we do it once, probably the Tcl is going to work. But if it's in a loop, it's in a high frequency loop, it's going to have to go. So let's talk about cpptcl. Here it is. What's nice about this slide is you're seeing almost all of it in one slide. And it is C++. So when I talked to Carl about cpptcl, We were talking about how to make Tcl more attractive to other programming communities. And one of the things about other techniques, not to criticize them, because it's in the perception of the C++ person, they're like, oh, I have to run a post processor. I remember CFRET. I am not running a post processor on my code, right? Does it work with my tools? My tools are very good. Is it going to understand the syntax, right? So what's great about cpptcl is it is C++. It goes into your C++ tool and works, and you don't have to ask the C++ person to change their code. If you have C or C++, it will work with cpptcl relatively well with some limitations, but for the most part, it is very, very convenient. So in this case, we want to provide this command hello to Tcl, and you can see up above there's hello is a free function. It doesn't have anything Tcl-y in it. It doesn't have anything not C++-y in it. It doesn't really do anything useful. We'll talk about that. In any case, then we come to the actual meat of the road. Did anyone guess what variable I is?
Intel.
The interpreter, yes. So, don't have to read a bunch of documentation. It actually contains one piece of magic that I will talk about. And in any case, we have our name of our function, In this case, I'm actually showing that, like, hey, you shouldn't make a Tcl function without a usage. That's mean for Tclers. So we actually create the usage inline. And Tcl is the namespace of the cpptcl library. It has nothing to do with official Tcl, right? So then we want to run it. cpptcl is really talking about dynamic libraries in terms of load. But of course, we wouldn't do this. We would put it into a Tcl package. We would create a directory and a package file, and in the package file we would do the load. But that would mean I have to teach you that Tcl, right? But if we had someone that was really like, I don't have patience for that, well, you can just load it, and you can actually create a package with just the load. So the goal is, the reason why we support it is I can go to the most combative C++ person and I've tried to remove every barrier I could possibly remove and say, like, well, you show me something that's simpler than this, because I see the competitors as Python and Lua, right, and trying to chip away at that. In any case, it's super convenient because debugging things and doing things in IDE tools does become simpler because it really is just a veneer on yield. Any questions right now? We're going to come back to some stuff. All right, now, it's really hard to compile and build and configure on your system. It requires one line. I hate it. It's so hard to use. So, literally, when we go to people and we're teaching programmers, there's all this magic memory stuff we have to teach them, which are rational and completely reasonable. And if you look at the G++ man page, it goes page after page after page after page after page. But we have to tell everybody at some point in their first week of work, like, oh, you got to say fpic with capital pick. Why capital pick, lower pick? We'll talk about that later. You have to say shared. Why shared? Oh, because this is that special file that we needed for the operating system, right? And then, oh, you have to say user include Tcl'2018. Why? Because this is where the Tcl header is. Why isn't it where all the other headers are? No, this, right? So we do have a very low barrier. We are having to say some things. I dog-fooded this the other day. I took a Docker container with Ubuntu Bionic, package install Tcl, you get 868 now, yay. Git clone cpptcl, make install, take my sample code, paste my line across. So we want the barriers to be really low. We don't have to talk about, to the sysadmins about installing stuff and putting things in special places and these things, right? Because of that, it's hard to use on OSX because OSX ships garbage Tcl. Sorry, it doesn't work for us, FlightAware, but I don't think it'll ever be fixed. In any case, and also for extensions, you're using Tcl stubs. So now when you talk about an embedded interpreter and other things you can do I have to use Tcl stubs, you unravel all of that, like, well, now we got to talk about it to really understand how to embed an interpreter and how linking works. So I intentionally bias the way the software is configured to make the common use case of making an extension be not require, oh, you have to say this. So everyone knows that when you use T, it defines you use Tcl stubs. It's in T. And you have to say that, or it says it, and getting it not to say that is very challenging. But it is sort of like, make the common thing easy, let's make the uncommon thing harder, right? So now, what can we do with it? You pick your build system, and C++ uses CMake. CMake is ironically Tcl. If you read the language specification and how it works, it's practically Tcl. I wish they would have seen Tcl. They might not have actually written their language.
They had seen Tcl.
Yeah.
I know the kidware people.
Yeah. I'm not in love with CMake, but we try to be sensitive to the community. And hopefully in the future, an improved fine Tcl CMake template. Right? So how does it work? All of the code generation is C++ templates. And what can we generate? We can generate functions, we can generate methods of classes, we can generate factories for classes, we can generate destructors for classes. It's very well rounded. It's coded to support 0 to 9 parameters. This is easily changeable, but Scala has a default of 11 instead of 9. And it's basically, mechanically, it makes the code very portable. And if C++ ellipsis improves, then it will be infinite. It won't matter, right? So what are the types? What does it understand? What can it write the templates for? So it understands bool, int, long, double. So of course, if you use float, it's going to get upcast to a double. std string, char const star, and std vector char, which is a little strange. If someone was actually doing std vector char, I would be like, let's make sure you really want to be doing this, because you might have a lot of copies. And of course, it actually understands C++ classes in and out of Tcl. You can give Tcl a C++ class, you can float around in Tcl and do things and be handled and stored, and then it can actually come back into your extension in C++, cpptcl. That's nice. So in any case, I'm going to show you some few more examples, but we obviously cannot go through all of the documentation in this process. Right? Okay, so here you go. Here's a class, a really simple C++ class. So if you don't know C++, it won't matter. If you do know C++, it's just a class with a variable. And then we want to get it into cpptcl. So we're parameterizing the template over the class. We're giving it the name of the class object. And this one has a constructor with a parameter. And we're telling cpptcl how to construct one, like what do you need on the Tcl side that ultimately you're going to call the constructor with. And then we define a couple methods as the method pointers. So this is not weird C++ either. We do not use anything exotic from C++, which is really nice, because it looks very much like Tcl on the inside. Actually, I think someone more expert than me could really vouch, but I think just the way delete is syntactically presented, there's a dash and there's not a dash. And otherwise, you can kind of write code that looks like Tcl. It's nice, and it works. And you don't have to write boilerplate code. Okay, so now, all this magic happened because of the cpptcl module macro. So what it does is it's going to create the global init entry point of our extension. Right? So when you write an extension, it must declare the capitalized, not in lowercase name of the thing it's loading. So it's going to take the file name, it's going to take that and trim off the lib and upcase the first character, and it expects this entry point. And it's going to create a C++ version of the wrapped interpreter called Tcl interpreter. And in our case, we've just been using the variable I, so it fits on the slides. Tcl CPP includes a lot of wrappers for the C pointers and classes, and they work and they're good. I don't put a huge emphasis on that to say, like, if you're writing a program and you've been writing to the Tcl C API to an embedded interpreter and work with it, and now, oh, you can go use cpptcl and it's going to look 1,000 times better. And I'm like, no, it's going to look more C++-y, and it's going to be, depending on your perception, better. It's not mechanically going to be particularly better. These classes don't really provide a lot of additions other than in a lot of syntactic sugar, which you can like. But I don't tell people, oh, if you're writing to the C API, that's not the way to do it, right? Because I'm like, well, I see that as very debated. You're adding a component that you're not leveraging anything about, particularly about C++, to any significance. Then you got to question if you're doing the right thing. There's more arrays. So when you get past an array, you get past a object, which is Tcl::, object, which looks a lot like Tcl object underscore object, right? And then if that object is an array, we can talk about that array using parentheses, and it looks like Tcl. So does this look like Tcl? I can't make it look any more like Tcl than that. So I tried. This is it. I could use a macro and I could make these curly braces, but the C++ people would be like, don't do that. So in any case, arrays have some nice support, and objects have good support in cpptcl. So like using a list in cpptcl through the object class is quite nice. Calling tcl from C++. So I wrote this thing, template macro called tcl bind. So here's our tcl in our C++ program. Does anyone notice anything about this string? Any C++ programmers notice anything funny about it?
Got that R close.
Get that weird R thing, and what that does is finally in C++, we don't have to escape quotes, and we can actually create multi-line strings. This could have nice. Except for if your tcl code has parenthesis quote in it. Then it would terminate the string. But otherwise, that's really nice about modern C++. Then we want to call the method. It takes two strings and it returns a string. So the way the template functions work, and this is actually the way like bind and invoke works, is the first thing is the return parameter, then you have enter more arguments. Exactly the same. C++ person might look at that and say, why are you using bind? We don't use bind anymore, you ancient C++. And I'm like, no, this is tcl bind. But it looks like the bind you C++ers know. Then once we've made this, you notice another weird thing? There's no interpreter. So the original cpptcl was really hooked into the multi-interpreter idea. And I said, let's look at all FA and say, how many instances of multi-interpreter do we have? So anyone with multi-interpreter in production, raise your hand. Right? Now, FA people, none. Okay? So for us, it's convenient to not have to pass around an interpreter all the time, and the framework actually caches the first interpreter it sees that gets constructed. So as I'm going to hang on to that, even though it's unsafe, it's super convenient, and we don't have to pass I around all of our code. And because we don't do multi-interpreter, it's not a problem for us. But if you're doing multi-interpreter, all the methods basically have another hidden parameter which has a default, which is the interpreter, and you pass the interpreter. You would have the interpreter, and you would manage where it is in a global variable that you set up somewhere because, hard array or whatever you're doing there, and you would pass it in. So the original cpptcl had interpreter like all over the place. And I said, let's make this the default parameter on the end. Makes the API a little cleaner to read when you don't have to have this concept of multi-interpreter in your project. So the interpreter here is implied from all the code that's going on around it. And the last thing is you notice when we call Tcl, it looks like C++. Doesn't look weird at all, right? And the syntax is exactly the same. And that's just because it's operator parentheses. So, questions? As it says the end. See if everyone's reading the slides. Put it in there. It's 26 minutes, so we got 4 or 5 minutes. Yeah, go ahead.
This looks fantastic. What about if what I'm implementing in C++ is something that cares about kind of more complex values as receiving from Tcl? If I get in something that's a custom object type and I know represents like a pixel buffer, and I want to do a get pixel buffer from objects, can you still do that?
So, I think what's going to happen in that case is that the crossing of the boundary is pointer associated. So you might, like for example, if your memory area is coming in as a Tcl object pointer, and you can cast it to your type and know that it's safe to cast it, that's the operation I think it'll have to appear. Because I don't think there's any code in the framework that kind of be cognizant of extended types. But it's just the thing is when it's crossing that boundary, you get object. It has a method that says, give me the raw pointer, and do whatever I need to do to take the API. It doesn't actually stop you from doing things, which is nice. You can always just open up the cork on the bottle and say, give me that good old C pointer, because I want to call some unwrap method that I'm going to call once in my programming career, and therefore wrapping things that, to just say wrap everything is crazy. Why do that? Why should don't wrap. Any other questions?
Yeah, on the example with the person where you said set person, whatever that was, how did you clean that up to go back to my talk? It said ... on the end. Do you have to delete it? Is it a Tcl object that might shimmer? Keep going back.
So there's no shimmering because Tcl does not have a type, right? It's just a pointer. So like if you shimmered it to an int, you're just going to get a gobbledygook number, right? It's just an address. It's useless.
It's a C++ object. Unlike a Tcl object, that's actually something in the interpreter. This is something that Tcl knows. I'm just kind of trading, and you have to use basically would have to destroy it from inside C++ to get rid of it.
Right, and the C++ objects are nude and deleted, or you provide a factory method.
Go back to the Tcl though. Mm-hmm. Go back to the Tcl where we use that thing. No? Yes. No?
So to free T, we have to call delete.
Right. So where does free get called there?
Nowhere, because we didn't call delete. We have to say.
So
we gotta say just like Tcl, we gotta say delete this object. $P delete. Right. So it will definitely leak if you don't delete. Right.
Okay. So you need the thing that I need to.
I don't know how we know. I don't know. Well, that's a good question. It's like, is there a hook for Tcl reference count? When Tcl reference count hits zero?
So what is the, is person Joe creating a Tcl obj type of Tcl obj, or?
Yeah, so it's creating the C++ object, and then when it goes into Tcl, it has to encapsulate that pointer in a
Tcl
custom
object.
type parameter.
In a what?
In a custom object,
Right.
that has the pointer.
With a Tcl obj type and Tcl obj.
Yeah, so Joe is a valuable Tcl.
Right.
Mary's a valuable
Right.
Tcl, and they get swapped out and converted to a C++ string. And I imagine cpptcl is probably doing some manipulation of the ref
Right.
count. behind the
So I
scenes.
bet if it's using that, I bet it can shoot. In which case, get name won't work anymore.
$P
Right.
is not the object. $P
It's
is
just a
regular variable. Takes the string P0xfsc, which is a Tcl command.
Oh, okay. Right.
Person
Okay.
creates
Right.
a Tcl command.
Yes. Okay. I see
With an
that.
arbitrary name.
So right. So that's a global object
Right.
in Tcl that will sit there until
Right.
you delete it.
So you delete it.
Okay. Yeah.
Yep.
Okay.
Yeah, you don't get any help for that. Yeah, I mean, what would be the concept of shared pointer in the API? How would I inform it? How would I provide it to this?
Yeah.
That goes back
Tcl
to
types might already do it. I don't know.
Yeah.
the meta graphics talk this morning.
Right.
Mhm.
And that's what I'm
Right.
asking the question.
It doesn't help at all with that. Like, you still have to be totally memories out the same there.
If that was, for instance, in the constructor of a class, that command would be together in that object's namespace, and when that's in that class, and then Tcl class goes away, that namespace goes away, and the command is removed, presumably that would trigger the destruction.
Right. Anything that
Yeah.
any kind of a destructor that gets called or trace or anything like that could similarly
that's-
delete that object.
Does that, well, the Tcl objects, I know if you rename the object to empty, the interpreter knows to blow it away. Here, if you renamed POX to nothing, it does?
You
Okay.
leaked.
Oh, you leak. Okay, that's
Yes.
fine to know too.
You have to call the delete, the destruction of it, or pass it to something as a sync that can delete it.
That should be trivial to fix, because when you register the Tcl command, you can provide a callback when it's deleted.
Right.
Yeah,
Yeah.
Yeah. You can
have
definitely.
to look at that.
Right.
It's probably already implemented.
And in fact, that's what you usually do in Tcl rather than, is you let the delete method handle it. Question, do you have a capability of handling template functions, at least that are polymorphic in the types?
I don't know why. I don't think it would have a problem with that.
Because all the examples I saw had explicit typing in the.
As long as the types they're generating are in the Marshall types, they will resolve. Right. Because it would rewrite that.
Right, but could I expose in Tcl something that takes foo1 or foo1.0?
You wouldn't be able to def it because it wouldn't be concrete. So like when you went to say def, you would have to be giving it types there because then it wouldn't.
Right, so that I can't create a polymorphic function in Tcl that's callable
No.
from Tcl.
Because it doesn't know how to marshal it unless you did. I mean, we could add like STD variant, but I don't like STD variant. I'm like, why are you writing this code? It's not going to be any faster than garbage code. But it would, take anything. But it's inconvenient, right? Like, why do that? So this is the point: is that like hopefully what the code we end up with is the same as hand coded.
Yeah, the reason I'm thinking about that is that swig wrap libraries such as ITK wind up generating combinatorial explosions of template types.
Right.
So, the ITK swig wrap library has got some tens of thousands
Yeah.
of Tcl commands, all with the type names embedded in the command name.
Right. Yeah. And that's not unusual for template, even in the C++ world and Scala world. That's kind of what happens.
Well, except that normally your template gets resolved with the arguments, and you don't have to spell all of that out.
Right. So Scala has an instruction to the compiler where you can tell it, I've got all these classes, permute them for me in the templates, and then everyone's like, my Scala compiler is running for 3 days, and it's doing what you asked it to do. It can do that, right? C++ doesn't have that mechanism. C++ doesn't have a way of driving the instantiator other than doing instantiation, right? So like
Yeah,
if you had
but
1,000, you'd have to write 1,000.
That's fine, but then what you're exposing in the Tcl API is is that you've got 10,000
10,000 names, right?
10,000 names and have to choose the right one on the Tcl side.
They could be. You remember what this is? You told me this the other, where you got like the what is it where you have like the first 3 parts of the command are in the namespace? They're not.
Oh, just ensemble.
Yeah.
Ensemble, yeah. But you'll still have thousands and thousands and thousands. But what do you do about that, right? I don't think there's a good way. I can't think of a good way because you have to invoke the compiler and the linker to get the code generated on the fly. So you got to have a code generator. So you might as well just use any other.
Well,
code
generating the code is one thing, and then dispatching to it is another.
Yeah.
It's
If you had a Tcl script go off and create a whole bunch of the send things, and then just
One thing to keep in mind is MUV Tcl is one of the types of arguments that you can have on the C++ side is object. And when you do that, then you can do your, okay, what type of object is this and stuff, and do your dispatching of the program. And yes, that puts a whole bunch of ifs in there, but that's a bunch of ifs that you're putting in there instead of the Tcl string of it, so probably faster and hey.
My really dream is that, like, if you got that problem, you know what to do. But if you have the other problem, which is, like we heard in one of the other talks, we did critical on one proc and got a huge gain, right? So can we bring all the memory safe C++ stuff into Tcl without requiring that community to actually bend at all is awesome, because there's so much software that how can we make it a win-win? Right? That's it. Thank you.